Today's topic is two-step equations. So we're going to learn how to solve and check. I'm going to make these a lot bigger so that you can see the writing. So let's look at number 1. Our main goal when solving two-step equations is to isolate the variable term. So we're still going to draw a line going straight down from the equal sign, so we separate that left and right side. And your focus needs to be wherever the variable term is. So circle that entire variable term. And then our goal is to get this variable term right here on one side by itself. So we want this by itself, so we have to get rid of this plus 3. So the opposite of a positive 3 is a negative 3. So we are going to subtract 3 from both sides. The 3's cancel, and you end up with a 2x on the left equals, and then 15 minus 3 is 12. Now we're left with a one-step equation, which is what we were working with before. And again, our focus is still on the side where the variable term is. Now we've got that term by itself. Now we want to get the x by itself, the opposite of what's happening to x. And 2 is being multiplied to x. To undo that, you want to divide both sides by 2. So remember, undoing multiplication means that you're going to divide. So the 2's cancel, and you're left with an x on the left, and then 12 divided by 2 is 6. So the solution is 6. And then we're going to check that. So we're going to start with the original equation right here. Always start with the original equation, and wherever x is, we're going to plug in the value that we came up with. So using substitution parentheses for your variable, I'm just rewriting the original equation, but without the x. And then we're going to replace the x with the 6 that we just set it equal. And then we're going to follow order of operations. So 2 times 6 is 12, plus 3 equals 15. The 12 plus 3 is 15, and that does indeed equal 15, which checks. Let's look at example 2. So for example 2, we're going to do the same process. We're going to draw a red line, and we're going to isolate this variable term. So we need to get rid of this negative 2. The opposite of minus 2 is a positive 2. So we are going to add, that's a terrible plus sign. So we are going to add 2 to both sides. Our 2's cancel. We're going to bring down the negative 3y. It's not just a 3y, it's a negative 3y. And then 4 plus 2 is 6. Now we have this one-step equation. We want to get y by itself, so we want to undo the multiplication here by dividing by the very same sign and same number. So we're going to divide both sides by negative 3. The negative 3's cancel, and we get y equals a negative 2. Then we're going to check. So we're going to start with the original problem, negative 3, and instead of y we're putting in parentheses, minus the 2 equals 4. So remember, that is our original equation here that we just wrote here, but without the y. We're going to replace that y with the value we just came up with, which was negative 2. Follow the order of operations. Negative 3 times negative 2 is a positive 6 minus 2 equals 4. 6 minus 2 is 4 equals 4. It does indeed check. Moving on to example 3. So example 3 is a little different. Looks a little different. It's got a fraction in it. Don't let that bother you. We're still going to draw our line. We're still going to circle the entire variable term, which means we need to get rid of this positive 9. So the opposite of adding 9 is to subtract 9. So we're going to do that from both sides. The 9's cancel. We're going to bring down the x over 6, and then 19 minus 9 is 10. Then from here, x is currently being divided by 6. So to undo division, we need to multiply. And we're going to multiply out to the side, 6 over 1, because x over 6 is a fraction. And on the right side, we're going to multiply by 6. I just didn't put it over 1 because 10 is not a fraction. The 6's here cancel, and you're left with an x on the left equals, and then 10 times 6 is 60. And let's check that. So again, I'm going to start with this original problem, but instead of x, I'm going to put in substitution parentheses. So here's our check. So parentheses over 6 plus 9 equals 19. So instead of x, we're putting in 60. So then 60 divided by 6 is 10, plus 9 should equal 19. 10 plus 9 is 19, and that does indeed equal 19. It checks. Example 4. So example 4 is similar to example 3, except for this time the variable term is over here instead of here. So don't let that bother you. We're still going to draw a line. We're still isolating this variable term, and so we need to get rid of a negative 2. The opposite of a negative 2 is a positive 2. So we're going to add 2 to both sides. The 2's cancel. And we're going to bring down the z divided by 4 equals 6 plus 2 is 8. Now we have a one-step equation. Z is being divided by 4, so to undo that division, we are going to multiply both sides by 4. So the 4's cancel, and we're going to bring down the z equals 8 times 4 is 32. So then we're going to check. So starting with the original problem, negative 2 plus parentheses over 4 equals 6. So instead of z, we are going to put in what we came up with, 32. So we're going to take the 32 divided by 4, because that's what we're going to work first. So we've got negative 2. 32 divided by 4 is 8 equals 6. Then negative 2 plus 8 is 6, which indeed does equal 6, and it checks. Example 5. Example 5 is a little bit different than the other 4 examples. You've got this big complicated fraction here and a very simple number. So we're going to use a concept called proportions. A proportion is essentially one fraction equaling another fraction, only this side's not a fraction. But I can make any integer into a fraction by putting it over 1. So we're going to take the 2 and put it over 1, so that's a fraction. And if you remember how to solve a proportion, we use cross products to solve. So we're going to multiply those two diagonals together and multiply those two diagonals together. That's going to get rid of our fraction. So essentially I'm taking negative 7 plus x, and I'm going to multiply it to 1, and I'm going to set that equal to 5 times 2. So we're going to distribute or multiply this 1 into the parentheses. Negative 7 times 1 is still negative 7, and then 1 times x is still x. So negative 7 plus x times 1 is itself negative 7 plus x. And then let's not forget to draw our line, keep track of the left and right side. And then 5 times 2 is 10 on the right side. And now we have just a simple one-step equation. If I'm going to get this x all by itself, I need to get rid of the negative 7. So the opposite of negative 7 is a positive 7. So we're going to add 7 to both sides, bring down the x, equals 10 plus 7 is 17. And then let's check. So we're going to take the original problem, negative 7, plus parentheses, all over 5 equals 2. So instead of our parentheses, we're putting in the 17 that we just got. 7 times 17, or 7 times 17 is negative 7 plus 17. We've got two numbers with opposite signs, so we're going to subtract and keep the sign of the larger. 17 minus 7 is 10. 17 is bigger, so it's a positive 10 divided by 5 equals 2. 10 divided by 5 is 2 equals 2. And since the left side equals the right side, it checks.